squared.
I'm gonna do 6x minus 4x, or 6x squared minus 4x.
Good. Okay, that's fine. All right, so now this is where we finally do the grouping. So you look at the first two terms and you find the GCF.
2x.
2x. 2x here. What goes inside parentheses such that when you multiply in, you get back to the previous line. Basically, you're dividing each of these by the 2x. So like sometimes what I show is divide by 2x.
3x minus 2.
Yes. Now you immediately write that over here to the right. And you have to figure out what goes in this middle position here. Again, such that when you multiply in, you get back to the previous line.
5.
Plus 5. So now you're almost done with your grouping. Notice that these both share 3x minus 2. So that factors out. So it's 3x minus 2. And then what's left over, 2x plus 5 equals 0. Be sure you're really comfortable with how I did that last part. Sometimes it's missed, but they're the same factors, so they factor out.
Yep.
All right. Now you said each
set
of those
both of them equal to 0.
Yep. I'm sure he can handle it from here. Give me the final answers, please.
2/3 and negative 2.5.
Yep. Perfect. All right. You got another one there lined up, or you got that down?
Yep.
Okay.
3x squared plus 14x equals -8.
Like this?
Yep.
Yep. So just like the previous problem, we got to move this minus 8 over. You're going to add 8 to both sides. 3x squared plus 14x plus 8 equals 0. You look for a GCF. You're like, is there a number that goes in all of them or a variable? The answer is no. That's when you take the 3 and the 8, multiply them together. And what you're hoping for is now two numbers that multiply to 24 but add to 14.
12 and 2.
12 and 2. So do you see this now? And this, this is, sorry, this is 2. Is
Yeah.
it 3x squared plus 12x or 3x squared plus 2x?
Plus 12x.
Okay. So I'd like you to take the problem from here. I'm happy to scroll up if you need to look at what we did in the previous one, but I'd like you to see what you can work out from this position.
4x plus 4. 2. X plus 2. X plus 4. -4, negative 2/3.
You give me your final answers. Give me the factored form first. Sorry, should have been clear.
3x plus 2 and x plus 4 equals 0.
Like this?
Yeah.
All right, just quick check on that. Yeah, that's correct. And you said x equals minus 2/3, x equals -4?
Yep.
Perfect. Okay. Do you feel like you have that process down now?
Yes.
Okay. What's next on your list?
X squared minus 16x equals -48.
Like this?
Yes.
All right, so we're going to move that 48 over. Always set it equal to 0. Okay. All right, now from here, you're looking for two numbers that multiply to 48 but add to -16. The reason we don't, this number over here doesn't contribute is because, well, I mean, it's 1, so it kind of does, but 1 times 48 is 48. This is the simplified case of what we just did. So you just looking for two numbers that multiply to 48, but add to minus 16.
Mm, negative 4x, negative 12x.
Yeah, so this one though, you actually don't need to do the X thing. You just can break it apart into the binomials. X minus 4 minus 12.
Okay.
Like you could do the whole minus, but it's like an unnecessary thing because X times X gets you back to the X squared. Minus 4 times minus 12 gets you the 48. And these work themselves out nicely.
Okay, so then 4 and 12.
4 and 12. Good.
Next one I have is already set equal to 0. 2x squared plus 17x plus 8 equals 0.
Like this.
Yes.
All right. So this is like the first two that we did. Got a number in front, 2, that's not a 1. No GCF here. How do you proceed?
Number that multiplies to 16. The S is 17.
That's
So
right.
it's 16, so then it'd be 2x squared plus x, and then
Right. Yeah.
and then 8 plus 16x.
Okay. So why don't you carry out the problem from here, and
Okay.
I'll check you here when you're done.
So I got x plus 8 and 2x plus 1.
Okay. I agree. Keep going.
X equals negative 1/2, x equals negative 8.
You got it.
Okay. Next one I have is 4x squared plus 8x equals 21.
Okay. So when you move that 21 over, it's becomes like this, minus 21. Does that look right to you?
Yes.
So this is just like the last one. You got to take that 4 and the minus 21. The operator carries with it. Minus
Okay.
84. Two numbers that multiply to minus 84 but add to 8. I presume you're using a calculator. You just sit there and start hitting the slash buttons, like 84 divided by 2, divided by 3, divided by 4, divided by, till you get one that you see will get you close here to this.
Yeah, I got negative 6 and 14.
Yes. So 4x squared, are you going to go minus 6x plus 14x, or are you going to switch them?
Minus 6x plus 14x.
Okay, so why don't you carry out the rest of the problem from here? I think you know what to do.
Okay. I got 2x minus 3 for one of my factored forms, but that doesn't work when you multiply it by.
So this is correct. The 2x minus 3 is correct. So what that suggests is there's maybe just a sign error or division error. So this is for sure 2x minus 3,
That's what I got for the first one,
2x
yeah.
minus 3.
I just can't figure out what goes there. What goes in the middle.
So look at the number, the constant here.
So
How do you
that's
get back to
minus 3.
how do you get back to 21?
Oh, it's minus 21, not minus 14. Or not
Yeah.
14. Okay, so then, yeah, no, I was right. 7.
Okay, so it becomes 2x minus 3, 2x plus 7 equals 0. Keep going.
Okay, so then 2x, 7, 2x minus 3 plus 3. Three halves, negative 3 halves, and negative 1.5, negative 1.5.
These are not, maybe I misheard here. Positive 3 halves, which is 1.5. If you want to do that, you don't have to do that. And then negative 7/2, negative 3.5. Is that what I heard?
Oh, no, I got that wrong. Okay. Well, I got 3 halves, but then I've said 3 halves for 7 divided by 2. So it's negative 3 and 1/2.
The
So,
preference is to leave it as an improper fraction, unless your teacher is strictly forbidden you from doing that. This is more of what you will see in a textbook or paper.
okay.
But if your teacher's like, I really want, decimals, okay, give them what they want.
And then next one I have 5x squared equals 13x minus 6.
Okay.
So then just subtract 5x squared, right?
Well, that's what I was going to say is the preference is actually to move left because you want the 5 to be positive.
Okay.
It doesn't have to be, but it works out cleaner for you in terms of looking like a similar problem here. So you generally move left, but really you're moving to, positive x squared, whatever that is. You want that one to be positive. It's the main thing.
Okay.
Okay.
And then x times x minus 2 x minus 2 minus 3.
Did you say 10 and 3?
Yeah, negative 10 and negative 3.
Yeah.
So then I ended up with 5x plus 3 and x minus 2.
Okay. So just, just because I think you probably would appreciate this, how I'm checking this. I mean, sometimes I'm going to another thing just to check them, but I can FOIL real quick. And I know the first and the last are going to be right. I'm just looking at the minus 10x and the 3x. So I know there's a sign error here because this one is should be minus 3x, which means this should probably be a negative right there. It's like
Okay.
5x times x gets me to 5x squared. Minus 3 minus 2 gets you to 6. And that's how I knew there was something wrong with this one because it was off by a sign. And that does impact your final. It's just a little, it's a little tiny thing there at the end, but it's like, you gotta work it all the way through.
Yep.
Start to finish there too.
So then is it positive 0.6 and then 2 or positive 3/5?
Yes. Yeah. Right.
Okay.
Doing good. What else you got?
Same kind of problem. 4x squared equals negative 29x minus 30.
Yeah, it's the same thing here. You're going to move everything to the left because you want your leading x squared to be positive.
Okay.
That's really important.
Okay. So then,
So go ahead and work this one out, please.
it has to multiply to be, it's 120. So add to 29.
Yeah.
Like 13 and 15.
Those don't add to 29. So
Oh.
they're pretty far apart. But just maybe like I said, like you just sit there and you start slashing to 20
Yeah.
/2 /3 /4 /5. One of them might jump out at you as working.
Anyway, oh, 5 and 24.
Okay, so 4x squared plus 24x plus 5x plus 30. Assuming you'll pair them up that way. Go
Yeah.
ahead and keep working this out on your own, please.
4x x plus 6 plus 6 and then 1x plus 5 and x plus 6 and that goes -5 and -5 over 4 -5 over 4 and -6. I got x equals -5/4 and -6.
You are correct. Just filling this in case you want to look at it later. All right. Hopefully you're seeing the pattern here of how to do these.
Yep.
It's kind of a straightforward recipe each time.
I got like 10 more of these, I think. Yeah,
How
10
many?
more.
How many more?
10 more.
Okay. All right. Well, it just I'll say this, that's probably going to take us 2 or 3 minutes a piece. That'll get us the end of our lesson. That's fine. But if you have other stuff you want us to look at, please let me know. We can keep working through these if you'd like.
So then this one says x squared minus 18x minus 81.
Like this.
Yeah.
Okay. Now we've finally got, and you like, there's no way any one of these signs are like, this one's not a plus maybe.
Yeah, no, it's a minus.
Okay. So if you start looking at all the factors of -81, there's not that many, but like
Oh,
1 in
wait,
81.
sorry. It's supposed, I accidentally did it in my head. It's x squared minus 18x equals -81.
Okay.
So
And
yeah, so it's a plus.
that changes things significantly. Yeah. Because now it does work, which is where I was leading you to on the one on the right. The original one did not work. And I don't know that you've seen that, but yeah, 2 numbers that multiplied 81 but add to -18. Do you have those for me?
9 and -9 and -9.
So you write x minus 9, x
Plus 9. Yeah, there it goes. Hello?
Hey, Braden, sorry about that. I have a little technology issue there.
That's fine.
I had to do a quick restart here and it just happened all of a sudden, of course. So I should be back here sharing my screen. I assume you finished this one out already, but it's x minus 9 equals 0, or x equals 9 for that one.
I think like we do maybe 3 or 4 more of these and then
Sure.
go into like something else.
Okay. Yeah. So whenever you're ready, go ahead and feed me that next problem there.
Okay. 36x squared equals 25.
Like this.
Yep.
Okay, cool. So kind of like the other ones, you do have to put this on the same side. This is a difference of squares problem.
Okay. So it's like I think a 6x.
Yes, that gets you back
yeah.
to the 36. What gets you back to the 25?
5.
5. So this becomes 6x minus 5.
Times 6x plus 5.
Yes. So it's kind of like we're going through all the different types of factoring that you might see.
5,
And
6, and then negative 5, 6. I think. And then what's 5 divided by 6?
so it's just 5/6 and minus 5/6.
Okay.
There is another way to do it where you don't factor, you just use the square root property. But yeah, that's just side note there.
Okay. The next one is x squared equals negative 2x plus 8.
Like this.
Yes.
Okay, so we got x squared plus 2x minus 8 equals 0. Why don't you give that one a try on your own, please?
To negative 2 and so x minus 2 yeah x minus or yeah x minus 2x and then x plus 4x.
So this one is not a grouping problem. Like you're mixing the groupings. When you have a number in front besides 1, that's when you do have to do this. If it's just a 1, you just look for 2 numbers that multiply to -8 but add to +2.
Oh, so then 2 and or negative 2 and 4.
Right. So x
Oh,
minus
x
x
minus
plus
2.
yes.
X minus 2. Yeah.
Yeah.
Minus 2. X plus 4. Oh, because I could have factored out just the x and it would have been just like more work, right?
Yeah. I mean, you're using the kind of it's like quadratic formula works for everything, but this, you only need to do the
Yeah, I understand. Last one, I think, yeah. So then negative 12x plus 4 equals negative 9x squared.
like this.
Yep.
All right. So this time bring the 9x squared left.
Okay.
So that's 9x squared minus 12x plus 4 equals 0. This is a couple of things. It's the grouping where you take the 9 and the 4, but it's also what's called a perfect square trinomial, or one of these, they call them a special product. I'm not sure how you're seeing this in class. It's like this one is trying to decide how even to show this to you, but it's a squared minus 2ab plus b squared. And this always factors into a minus b squared. If you haven't seen that, or you don't feel like you can remember that, you just do the grouping thing. 9 times 4, 36, two numbers that multiply to 36, but add the minus.
Yeah, I'm
minus
just gonna do
12.
grouping.
Okay.
So then, uh, add to -12. Add to -12 multiply to 36. There's 36 divided by stuff. 36 divided by 2. No. 36 divided by 3. No. 36 divided by 4. 9. No, that doesn't work. Oh, -6 and -6.
Yeah. So it's 9x squared minus 6x minus 6x plus 4. Keep going from here.
And then 3x. We have 3x minus 2 to that side. And then -2. Yep. 3x minus 2 squared. And then was so plus 2, so 2/3, so 0.667. Yeah. That's the same answer twice, right? Like it has it's a double root, I think is what it's called.
Exactly. And that's one of the reasons you might have been able to do it, perfect square trinomial type, but that's okay. It, it worked out just fine there.
Is there anything you felt like I needed help on yesterday, like that I struggled on then?
Yeah, I mean, and I say that because I want to help. It's not like I'm like, like,
Yeah.
I really wanted, like, I noticed, it's like, man, like there's a few things here that seemed unclear that I thought you would know before the test. So the first one was I thought had to do with transformations here. Actually, no, I take that back. It was the first one was this graphing of a cubic. So let's say it's minus 2x cubed minus 8x. Okay. So it said here to use zeros. Basically, I want you to find the zeros of this. You set it equal to 0,
Yep.
and then you apply some sort of factoring technique to this. Sorry, this let me this needs to be a plus for this to work. There we go.
Factor out 2x. 0 equals. And factor out -2x. -2x and then x squared plus 4x and plus 4. Yeah, x squared plus 4. So that leaves me with 2 solutions, but I need 3.
Did you get x squared minus 4 inside here? I'm sorry, wasn't quite following.
Yeah.
Okay, so you got to factor this in here. This is difference of squares.
Oh, okay. So then -2x is its own little parenthesis, then x minus 2, and then x plus 2.
Okay, good.
And then it's x equals 0, 2, and then -2.
Okay. So there's your 3 zeros. You said you got them one at 0, 2, and -2. And so when we went to the graph, here's 0, here's -2, here's 2. The question was, well, how do you know which way it goes? And I recommended testing a point in between one of them.
Yeah.
Like maybe 1, something like that.
Mhm.
So what does anything
So,
there stand out to you?
so when you plug in 1, you get 2. Yeah, -2 plus 8 is 6. So it'd be 1/6, which is high, which means it probably start at like
Basically, does it start up here or down here is what you're trying to decide.
the first one, the third quadrant.
The top one?
Yeah.
Yes. Something like that. Any questions on that?
Mm-mm.
All right. So while I'm trying to find another one like this other one here, I remember having issues. Let's have you determine the transformations of the following. Let's go P of X equals -1/3 X plus 2 squared minus 3. So there are 4 transformations here, if you can think about those.
So to the left, 2, down 3. This is vertical shrink by a factor of 1/3. And reflected over x-axis.
Okay. Very good. All right. What is the vertex of this?
-2, -3.
Good. And does it have a min or a max?
A max.
It has a max. Yeah. Okay. What was it about that one? So you sent one. Oh yeah, that one was okay. All right. So let me have you try this one here. I want you to graph something like this here. So we'll go -2x squared minus 3x plus 9. Okay. And I want you to graph using the zeros. Okay. So basically you've got to do the same type of grouping that we've done. The difference here is that there's a negative in front. If you see that, we never really dealt with negatives. So just as a hint here, I will factor out that negative to start.
Okay, I'm just finding the zeros.
You're finding the zeros just to start, yeah. And then we'll talk about what to do after that.
Okay. The zeros I got are -3 and 1.5.
Yes. So the factored form should look something like 2x minus 3, x plus 3, like that. And you're right, you've got one at -3. And then +3, 3/2 there. This one's a little bit harder to determine the vertex. So let me instead have you find the y-intercept.
Okay. Y-intercept. I got 9.
Okay. So notice the problem with my graphs, I don't have it scaled very well. So let me sneak this down a little ways. I don't know if that'll do it. We'll go one more here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see how this one opens down?
Yep.
Okay, and
Because
actually
it's negative.
I've done this wrong. The vertex is actually further up there,
Yeah.
but I think you get the idea there on that. Okay, so that takes care of everything on page 1 that I remember there sort of being some hesitation on from you. But I mean, overall, I think you got it. It's just like a little more would help here.
Okay.
All right. Okay, yeah, here's a good one. Let's go. And this is finding the zeros. Okay. Let's go x to the 4th minus 10x squared plus 9. So this is like a higher order factoring that we hadn't seen until we did this problem here.
Okay. Oh, it has like 4 solutions, right? Or is it 5?
Possibly.
Or is it 5? Because there's an x squared.
The exponent tells you the number of solutions.
If the x, but there's 2 x.
The highest degree power tells you the number of
Oh,
solutions. That it's considered the fundamental theorem of algebra.
okay. So then I have to factor this out. And then you get x squared. So you factor out x squared, and you get -5 plus 9. Or
What's your first factoring here? I think I heard it. X squared
yeah, x squared
minus.
5.
Nope. It's two numbers that multiply to 9 but add to -10.
Oh, so x squared probably -1 or +1.
They have to
Yeah.
both be negative.
Oh, then. Oh yeah, then x squared minus 9 too.
Okay, keep going.
And then those are both. So there'd be x minus 1, x plus 1,
Okay, keep going.
and x minus 3, and then x plus 3. So then you
Okay.
get 1, -1, 3, -3.
Yes. Let me give you one more like this. It was right in the middle of grabbing it for you here. Just want to make sure it works out nicely.
Okay.
All right, so this we'll call this one we'll go like q of x. I got it here. Let's go x to the 4th plus x squared minus 20.
Okay. So then it'd be in factor, it should be x squared or that's to multiply -20, but
Okay, and
add to 1.
yes.
Oh, -4 and 5. So x squared minus 4, and then x squared plus 5.
Okay, keep going.
So then it's x minus 4 and x minus 2 and x plus 2. And then
Okay.
I don't know what the square root of 5 is, but
So
x.
the one on the right does not factor, so you just leave it at
Oh,
that point. So you actually ignore it. You just look at these on the left. Maybe I should
but
have changed this. Like I was trying to just get you to do another one like this.
oh, okay.
If it was x squared minus 5, sorry for interrupting you, you would take the square root of 5. But
Okay.
you don't have that here.
Okay.
All right, so let me I'm working on a graph here of something like that. And then let me see if I can move this. No, I don't like that. Oh, why is it not working? Try to get you a nice one here. This doesn't work out. All right, so those numbers aren't any good. All right, that'll work. Okay, so here is, and I'm gonna just this is kind of like that graphing problem where they gave you the graph and then we asked a bunch of parts to it. So I'm getting the snip here ready.
Okay.
There it is. All right, there we go here. So here's the graph, 2 intercepts. There's the vertex. The first question that you were asked here is to find the domain, range, and zeros of the function like this. So happy to help here, but let me know what you think. Or
Okay, so the domain is all real numbers.
okay,
The range is y is less than or equal to 12. And the zeros are 2, 0, and 60.
yes. Now there's the I'm just gonna add some in, but yeah, 2060. You got it. All right, the next problem here, it said to write the function in standard form. So I'll just keep sliding the graph down here. The standard form is that ax squared plus bx plus c.
Okay.
Do you remember how we did this the other day? There's a couple of options here.
So A is always the same.
That's true.
A is negative B over 2A. Can't we just use the zeros?
So you can use the zeros. So it becomes x minus 2,
Minus
x
2,
minus
X
6.
minus 6, yeah.
But
Plus, no.
you have to use an x and a y to find a.
Yeah, so then it'd be 12 minus 2 is 10 times 12 minus 6 is 60.
You're using the y value. You gotta use the
Oh,
x value.
so 12 equals 2. 12 equals -4, so A equals -3. So f of x equals -3 times x minus 2, x minus 6.
Okay, this is great. This is not standard form though. This is factor
Yeah,
form. What will you do from here?
Standard form is ax plus by equals c, right?
Ax squared plus bx plus c. Yeah, you gotta get a FOIL and then multiply everything by -3.
Oh, okay, so then x squared minus 6x minus 2x 12. So then negative 3x squared minus 8x plus 12.
You're off on
Or
you're off on that.
minus 4x. Because -6 minus 2x. So minus 4x.
Still off. Still off here. This is the part you want to do first, please.
Yeah, I got
Unless I misheard you here. This is what I heard. Is that what you said meant?
Yeah, that's what I got.
Okay, still off here. So the FOIL here is x squared minus 8x plus 12.
That's what I said the first. Wait.
So you have to multiply everything by -3. Everything.
Oh, so then minus 3x minus 24x
Plus 24x.
Yeah. And then minus 36.
Okay. It's just the little things that are going to catch up with you. Maybe not in this class, but in others. So really, that's why we want to do as much as we can to do that. All right, last one here is to compare to the graph of f of x equals x squared, or g of x equals x squared. Let me grab the graph here one more time. Okay. The best way to do this is if it's in vertex form, which you don't have. But you can get it. You can get it
Yeah,
from the
so
standard form here.
then it's 3, it's negative. Yeah, so it's still -3 for A. A is always the same.
This is your vertex and that's your shortcut. You don't
Yeah,
have to
so
complete the square. Go ahead.
x minus 4 squared times or plus 12.
Yes. Now you can give me the 1, 2, 3, 4 transformations.
So it's reflection over x-axis. To the right 4, up 12, and then vertical stretch by a factor of 3.
Good. You got it. All right. Well, I mean, I feel a lot better, for you